Hi there. So today we are going to be talking about hash functions. Now, if you work with blockchain or you talk to somebody about blockchain, you are going to hear the term hash functions a lot, or you're going to hear different variations of the term hash. So today I'm going to go through exactly what hash functions are, how they're used, and why they're important. But before I get started, let me remind you to hit the subscribe button, hit like, and then ring the bell so you're notified anytime I publish new content. So let's look at a couple of ways they're used. So first of all, you'll hear the term, we hashed the documents, or we only store hashes on the blockchain, or what is your hash rate? Okay, so those are different terms that are based on this term called hash, and hash is derived from a function called a hash function. A hash function is a way to take a piece of data, let's say a full-size document or a block of data or some piece of binary data, and reduce it down to a specific size. Okay, and that is called the hash value. So normally the size of a hash that we would be working with is 32 bytes, which is 64 characters. So we could take any size document, it might be a 2 megabyte document. We run this hash function against it, and it creates a digital fingerprint of the document, which is again 32 bytes long. What this does is this creates a digital fingerprint so that the data can be validated. So I can take any amount of data, again, I can hash it down to 32 bytes, and then I can use that fingerprint of the data to ensure that the original data was valid. So a hash function is what's called a one-way function. They also are called trapdoor functions. Now what this means is it's just like your fingerprint. If I take a fingerprint of myself, my fingerprint can be used to identify who I am, but you can't rebuild me from my fingerprint. So that's where that concept of a one-way function comes in. So I can share a fingerprint of my data without actually sharing the data. Hash functions have some pretty important attributes that are what makes it useful in a lot of different areas, including blockchain. First of all, a hash function is very precise. If I change a single byte within the source data, the hash is going to change dramatically. So when we're using this for prevention of altering data or altering documents, it's important to know that just a single byte change in the source document is going to change the value of the hash fairly dramatically. So the next thing that's important is that the data is unpredictable. It's impossible to look at the source data and then from there determine what the hash is going to be. So if somebody tells me there's a document and this is the hash value of the document, I can't take another set of data and alter it in such a way that I come up with that same hash value. Now, hash functions are actually public. So if I have a hash function that I use, and let's say it's written in PHP, and I have some hash data and I give it to somebody else who's using Python or Go or JavaScript, the fact that the hash function I'm using is public means that I can hash a document with my function, and then someone else can hash that document using a different programming language, and they will always get the same value. Now, the hash that we see the most in blockchain is called SHA-256. The hash functions are actually very flexible. There are different hash functions that have different features. So some hash functions are faster than others. Some hash functions won't work on certain types of equipment if you want to prevent hashes from being run on certain types of devices. So you don't always have to use the same function, but everybody needs to know what function it is that you use to hash. Now let's talk about what hash functions are used for. Now the standard reasons you would use hash functions are things like digital signatures and validation of data. So digital signatures are an important topic in blockchain, so there's another video that I have dedicated to digital signatures, so make sure you subscribe and make sure you watch that video. The other thing is data validation. Again, because what a hash function does is it reduces a large amount of data down to something that you can easily calculate and that you can easily verify. Hash functions use a lot of different ways for data validation. Now, when we're talking about blockchain, hashing is very key in what's called data dependency. In the blockchain, each block is dependent on the prior block. So what you will do is when a block is created on the blockchain, a hash function is run and a hash is created, and then that hash is used in the next block, so that you can't change a previous block without changing every block that comes after that. So that's the concept of data dependency, and that's a really important key to blockchain. That's actually, hashing and data dependency is one of the things that makes blockchain what it is. Another thing that it's used for is proof of authenticity on the blockchain. That's very important because that's one of the very important uses of the blockchain. And then it also creates flexibility in data storage. If I'm storing something on the immutable ledger, which is how blockchain stores data. So what the immutable ledger means is once data has been written, it can't be changed. So if I take a block of data, I hash it, and then I store that hash on the blockchain, that's as good from a cryptography standpoint as storing the entire block on the blockchain. So hash functions create a lot of flexibility in the way that data is stored in blockchain architectures. Now again, that's something that I'm going to talk about in great depth in other videos, but I thought it was important to talk about here because it's one of the main reasons hashing is so important. Next thing I want to talk about real quick is performance of hash. Hashing gets slower when the size of the data increases. So if I'm running a SHA-256 hash on, let's say, 1K of data, and then I run that same hash against let's say 100 megabytes of data, the performance of the hash gets incredibly slow because it actually has to go through all that data and compare data and combine data, and hashing performance gets really, really slow as data size increases. And that's a limitation of this one technology that's overcome by the way different technologies are used within the blockchain together. So an example of that is how hashing is used in other areas of cryptography. Specifically, I'll just talk about something real quick called a Merkle tree and a Merkle root. Because hashing is something that's inconsistent in the amount of time it takes, when Bitcoin was developed by Satoshi Nakamoto, he needed a way to make sure that the hashing time would be consistent across the blockchain, no matter how large a block was. So there's a technique called the Merkle tree, which was developed in the late 1970s by somebody named John Merkle, who came up with a way of hashing hashes. What you see with blockchain and you see with technologies like hashing is that blockchain is really good about working around the limitations of whatever technology you've got. So in this case, with hashing, as it degrades over time, they use other cryptographic methods to work around this limitation. So working around the limitations of different technologies and putting them together in your blockchain architecture is something that's really important and something that you're going to see more and more as you get more and more in depth into blockchain. Okay, so that was my introduction to hash functions and hashing. I hope you found it worthwhile. I hope you subscribe to this channel, watch some of the other videos that we've got on the different elements of blockchain, the different elements of cryptography. And again, I hope to see you soon. Thank you.